All right, so I decided to split the video into two here. Second part will be division. This is division, and the rules still apply where if you're dividing same sign, it's going to be positive, and if you're dividing two different signs, it's going to be negative. And I'll show you what that means here in a second. And that's basically what this says. All of it with same signs and different signs. You can see all of the results for same signs are plus, all of the results for different signs are negative. All right. In terms of dividing, this is going to be called keep, change, flip. So I referred to it as keep, change, flip the other day. It's going to be different than keep, change, change. And we'll talk about why. But you're basically turning the division into a multiplication problem. Now those are opposites, and we can do that, and I'll show you how. In the same way that I showed you that you can turn any subtraction problem into addition using keep, change, change. So very similar processes. This one's called keep, change, flip though. All right, so let's get to the examples. All right, so first example, negative 27 divided by 9. Looks like a fraction, and it really kind of is. Fractions and division are the same things. You can think about it either as reducing a fraction if you want, or dividing, as long as it looks like this, obviously. So if you want to think about it as reducing, both of these numbers are divisible by 9, so you can make it, negative 3 over 1, which is negative 3. So if you want to think about it as reducing, it is the same thing as division, because negative 27 divided by 9 is, 27 divided by 9 is 3, and then it's a negative and a positive, different signs, so your answer is negative. All right. All right, let's do an example with fractions. All right. So first thing we need to do is make sure that these are both improper fractions. So 4 times 3 is 12. 15 over 4. Only one negative. I'm going to put it up top. Divided by 8, 9, 10, 11. Now, what's nice about division and multiplication is you don't need to worry about a common denominator. Even though we happen to have one here, we don't need one. All right. And so what we're going to do is, we're going to do keep, change, flip. Similar to keep, change, change, keep negative 15 over 4. Change the sign to its opposite. So it'll be multiplication, and flip the fraction, or get its reciprocal is what that's called. Oops. All right, so we flipped it. And so flipping means, so only do this with division. We're just going to flip the 11 and the 4. All right. From there, you're just going to multiply straight across. So we changed it to a multiplication problem. So the rules that we just used apply. Negative 15 times 4 is going to be negative 60 over negative 44. And remember, if the signs are the same, your answer is going to be positive. So we're dividing a negative and a negative. So the answer will be positive, first off. And then 60 over 44 can be reduced. They can both be divided by 4. So we'll have 15 over 11 positive. All right, so feel free. And by the way, like I said before, pause the video, go back and watch it, follow along. If you have an example like this, follow along with it, so you can get it done. All right, final example. Negative 2.3 divided by negative 2.0. Now, this is where we're going to have to go back to old school dividing. So the first thing we can do, and here's the thing, if you do it to your whole expression, it's totally fine. So I put it in brackets just to show you, and I'm going to multiply everything times 10. What that does is it makes everything, it moves the decimal place 1 over, So now it's negative 23 divided by negative 20. It's the same problem. We just altered it in a way by multiplying by 10, but that's allowed. I'm just going to erase it so it looks a little cleaner. But yeah, it's the same problem. If you do something to the entire expression, it is okay. It remains the same. For multiplication and division, anyway. All right, and so in order to divide from here, we want to just do classic division. Now, we know negative divided by a negative, same sign, is going to end up being positive. So let's just deal with the numbers as positives then, and it's 23 divided by 20. So hopefully you've seen old school division like this. We're trying to see how many times does 20 go into 23. So it goes in one time. 1 times 20 is 20. So you're going to put that 20 there. You're going to subtract, and what's left is 3. What's left is 3. Now, we don't have anything else to go, so we're going to have to go into decimal. So we'll put a decimal place here and here. We'll put a 0 for here for now, so we can bring it down. It's kind of a placeholder to keep our division going and get us going into the decimal. How many times does 20 go into 30? It goes in once. 1 times 20. There, subtract. We're left with 10. So we add another 0. Bring it down. It says 100. How many times does 20 go into 100? It goes in 5. And what's awesome is now we're done. 5 times 20 is 100. You can subtract 100 minus 100 and you get 0 at the end there. So that's just saying that 100 minus 100 is 0. That's our answer right here. 1.125. Or sorry, 1.15, not 1.25. 1.15. And that's division. And that'll be it, guys.